Small tutorial will help you go through the motion planning engine on VRIP. Okay, so usually this is a new scene, and usually in all of our labs we've been using the Baxter. One of the particular things that the Baxter has is that if you go to this calculation model over here and check where it says motion planning, you'll see that he has already declared a motion planning setting for each arm, okay? So if you go and do that with another robot, for this we're going to choose this robot over here. This one is one of the KUKA robots, okay? So if we go to the model and go to motion planning, you'll see that there's nothing in here, okay? So we cannot use the motion planning engine that VREP has like this, okay? So I'm going to teach you how to set up this motion planning configuration so you can use the motion planning engine for all of the robots that you're seeing here, okay? So what we're going to do is first we have to select all the joints, okay? So you can do it manually, like just by hitting Control, selecting Control in Windows and Command in Mac by pressing it, holding it down while selecting all the joints. Or the other thing that you could do is there is a selection icon in here, and you can select all of one object type. So for example, if I click joints, all of them, I'll select all the joints, okay? So you can do this for your robot if you want. Okay, so once I've selected all the joints have this particular icon figure over here, so that's this. They have this icon and they're called joint. So this is a way to identify the joints from the rest of the robot structure, okay? So once you have them all selected, you go to the calculation model again, and you go to the motion planning and you click add new object. It'll immediately add the object motion planning setup with all the joints that you've just selected. Okay, so I'm going to change the name to this robot is called the KUKA, let's see, LBR4, so I'm going to write LBR4. Okay, so maybe LBR4 and then motion planning. Okay, so this is his name. Okay, so this motion planning setup will start telling you the things that you need for it to be complete. Okay, so the first thing that you need is an associated inverse kinematic group. Okay, so to create an inverse kinematic group, what you need is to declare a tip and a target. Okay, so the tip is the element that will follow the target, and you usually do it with dummies. A lot of robots come with a dummy already in its tip, but this one doesn't, so I'm going to explain how to do it. What you have to do is click anywhere on the scene and click Add Dummy. Okay? We're going to add two. One, and here it's added. So we're going to add one for the tip and one for the target. Okay, here's the second one. So I'm going to call this one, if I double click it, I can edit it. So I'm going to call this one tip, and I'm going to call this one target. Okay, so the tip, I'm going to put it under the last link. Okay, so this is the last link, like link 8. I'm going to put it under here because then it would be at the end of the kinematic chain, and usually the target would put it at the base of the kinematic chain. In this case, it can be the whole robot, but for example, in the Baxter, we usually use the main body as a base, because then the kinematic chain of the arm will start in the body. Okay, but for this one, we can use the robot. Okay, so Okay, what I have to do next is that I have to give the tip the position of this link. Okay, so what I'll do is I first select the tip and then I select the link that I want to give the position of. Okay, and then I click this position icon over here and I just click apply to selection. And if you see now the target, let me move it a bit. And zoom out a little bit. Now, if you can see, if I select the tip, it's right here. Oh. Oh, it's here over here in yellow. Okay. Tip. Okay. Okay, great. So for the target, we want to do the same at first because if we set it up in inverse kinematic mode, what it'll do is the tip will follow the target. So as a starting position, we want the tip and the target in the same place. So what do I do to give the target the position of the tip? I first select the target, then while pressing Control in Windows or Command in Mac, I'll click tip. And then I do the same. I go to the position orientation window and then hit apply to selection. And then now, as you can see, the target it's already in that position too. Okay, so what I have to do now is declare this as an inverse kinematic chain. So what do? I can do it from the tip or from the target. It doesn't matter. So I'm going to do it from the target in this case, but you can also do this exact same from the tip. So if I double click in its icon, this scene object properties window will appear. Okay, so what I have to do is here when it says link dummy, if I'm in the target, I'll search for the tip, and if I'm in the tip, I'll search for the target. Okay, if I click tip, it'll automatically say that the link type is inverse kinematic tip target. But if in case it doesn't select this as the default, you select it. Okay. So this is all that you have to do over here. And now if you go to your scene hierarchy, you'll see that the tip is connected by a red line to the target. Okay, so now we're ready to declare our inverse kinematics group. Okay, so in the motion, in the calculation model over here, we go to inverse kinematic tab, and then we say I add new IK group. Okay, so you add it, and let's call it all LBR4, and maybe we'll call it IK. Okay, so this is a name, and then we hit to edit IK elements. Okay, so in here we have to select the tip. Okay, so we select the tip and then hit add new IK element. Okay, so it's the things that you have to be aware of is it has to say that the element is active, and we should select that the tip follows the target not only through X, Y, and Z, but it should also match the target's orientation. So we should click this too. As a base, instead of selecting the whole world, we should choose the base that it's under. Okay, so if your robot it's under if the target that it'll follow it's under the robot, you should choose the robot. Okay, so we're going to choose the robot, and then we hit close, and then it should say that now it's containing one IK element instead of 0. Okay, so be sure that this is not on explicit handling, that this is not selected. It should be like this for now. Okay, so now if we go to the motion planning tab and select the motion planning configuration that we just declared a few minutes ago, we can go to associated IK group and select this. Okay. Okay, it should be handled, I'm sorry, it should be handled as explicit handling. Okay, so we go to inverse kinematics model and click it as explicit handling. Okay, so this one should be on. Okay, we go back to the motion planning and it doesn't give us the warning anymore. Good thing is that for this to work, if anything is wrong, it'll tell you in this window that something's wrong. Okay, so This is the self-collision check, so this one checks if the robot can collide with himself. For now, I don't want the robot colliding with all the other collidable objects in the scene. And it says that it will check for collisions. And I'll do the same thing for obstacle collision check. Okay, so I don't want the robot to collide with all the other collapsible objects in the scene. Okay, so this is ready, and for this part we can now move the robot using the motion planning engine. Okay, so I'm going to change scenes, and I'm going to change to this scene that I'm going to give you. Okay, so this one says motion planning engine. This is going to be uploaded in Blackboard. Okay, so this is the same robot, and it's being configured the same way I just did. Okay, so here's the IK group in the inverse kinematics tab in the calculation model. Okay, so it says the group is active and it has explicit handling, and if I go to edit it, what it's added is the tip. As you can see in here in the hierarchy, I have a target and I have a tip, and the tip is under the last link and the target is just under the robot. Okay, so and as you see, when I select this, it's matching all the position and the angles, and it says that the base is the robot. Okay, so it has the same configuration. If you go to motion planning to check, it'll have the LBR group. Okay, so what is different? I added this cuboid over here. Okay, so if you see, there's this cuboid over here. I'm going to move it away for a second so I can show you something. Okay, so this that you see here, as you can see, the tip is right at the top of the robot, but the target, it's not in the same position anymore. It's right down here. Okay, so if you go here, you'll be able to see the target in here. Okay, so if we go to the code is right here for the robot. This is what you should see. Okay, so we're going to the end because at first it's just this function declarations that the demo of most robots come with. Okay, so this is all the functions that VREP demos come, so you can manipulate the robots using the motion planning engine. Okay, so if we go down to where our declaration starts, what we need to do is declare, I'm going to delete this so I can do it from the start, is declare at the target. Okay, so the target that we want to declare is this target over here. Okay, the target that is in the hierarchy as in here. Okay, so I'm going to declare it right now. I hit target. I'm going to name it target, and to declare one of the scene objects in your code, what you have to do is use this function that is called sim get object handle. Okay, so I write sim get object handle, and if you wrote it right, it should light up in red. Okay, so inside the parentheses, what I'm going to put is, I'm doing this because for some reason it doesn't let me use the quotation signs in this editor, but I know it does not happen in Windows, so this might be just a Mac problem. Okay, and what I do here is I put inside quotations the name of the target. Okay, so this one is called target, but if the name that I used here is target, for example, ABC, just to give you, let me double click it, target ABC, just so you show, the name in here should be ABC too. Okay, so this is the name of your object in the scene. Okay, so now that we have our target, we go to this part over here. This, what it does is, it tries to what the important line is here in here is this one. It actually, what it does is it tries to find the best path. Okay, so what you do here, I'm going to give you this code, is you in the third element of this function. Okay, so it has a lot of inputs, and on the third input I should put target, okay? The target that I declared over here. Okay, so I'm going to explain a little bit what all of these are. So when you're finding the best path from going to make the tip that's over here to the target, I only need to declare the target because the tip it's already linked to it. Okay, so it knows on behind that this target is linked to the tip. Okay, so what this does is in here what I declared, and you can see these variables. If I select them, you can see them over here. Is in here I declared I got all the handles of the joints in the scene. Okay, so this one goes from 1 to 7 and it gets all of the handles of the joints. The joints are named the exact same way, like as you can see here, LRB for P joint 1, joint 2, joint 3, joint 4. So the only thing that changes is the number. Okay, so this one goes from 1 to 7, changing the number of the joints and saving that object handle in this variable, in this array over here. And this one gets the joint type of the joint that we just got the object handle in here. Okay, so this one has all the object handles for the joints, and this one has all the object types. You don't have to change this code. You can use it as it is. What you do have to change though is that if you select another robot, you have to change the name of the base name of the joints here. Okay, so we do this here. The next thing that you have to do, okay, so these are the joint handles, and the next thing that you see that this function receives is MP. MP as the motion planning handle. Okay, so this should be the name that we use to declare our motion planning. So if I go to calculation model and check in motion planning, the name that it has here, LBR group, is the name that I should use in the motion planning handle. So I'll just write LBR group. Okay. The next thing that it's important here is that when I say base handle, it says Baxter, but it can be because this code is actually, I got it from the Baxter, but it should be just the base handle of the robot. Okay, so for this one, I declare the base handle as the robot. Okay, because this robot it doesn't have 2 arms, so the base of this actual kinematic chain is just the start of the robot. Okay, so I put just the name of the robot object in here. Okay. And now I can use this part of the code over here. Okay, so the things that you need in here. Okay, oh, this one I should delete. Okay, we have our target in here. Okay, so this is a max velocity, max acceleration, and max jerk of the robot. You can change this if you want for the robot to move faster. If you go up, and this one, if you make it go down, it'll stop in a so much more smooth way. Okay, iterations. This is a number of iterations the motion planning engine should do to find the correct path from the tip to the target. Okay, so this line in here that says SimRide custom data block, what it does is, as you can see here, we are trying to load a path. Okay, and in here we save this path. So what happens is that when we try to find the best path, these calculations take a little bit of a while. So what people usually do is the first time you run it, you let the motion planning calculate the path, and then you just save. If you got a path, and this is what it's checking in here, you save that path under this name. Okay, so this way the next time that you run it, it doesn't calculate the path again, but it just replaces the path that you already saved. Okay, so what it basically does is it tries to look for already loaded path in here. Then if you don't have a path already under the name of path 1, what it does is it tries to find the best path, and then if it did find the best path, it saves it in the same variable that we tried to load before. Okay, so for the next time it actually loads it. And then if you actually have a path, then execute the motion. Okay, so this one code you use should use exactly the same way. So the only thing that you should change is actually the name of the path. If you want many paths, you should change the name of the path where you're saving it. Okay, so now I can explain what this line is about. Imagine that you already saved the path in path 1, under path 1, and then you suddenly moved your target and you don't want that path saved anymore. So what you do is you use this line, and what this line is doing is it's deleting all the paths that you've saved before. So this, what it means is it's basically saying, please recalculate all of the paths. Like, don't use any of the paths that I already saved. Okay, so if I have this line activated and I go here, what it will do, as you see, it's trying to calculate all the paths, and when it finds the best, it moves towards that path. Okay, so if I stop it and I go to my code again and I comment this line, if I make it inactive, and if I comment it, it will actually use the path that I already saved. Okay, so as you see, if I hit play, it won't calculate anything. It'll just go straight to the point. This one is just replaying the path that I already saved. Okay, so you see, usually when you're doing a simulation, this is what you do. You first play your whole scene, calculating everything, and then you just replay it a second time with everything saved, so it doesn't take as much time. Okay, so what I'm going to teach you now is a little bit about collisions. So this cuboid, I added a cuboid to the scene, and if I double click it and go to the Common tab, you'll see that I selected it as collidable, renderable, and detectable. Okay, so if you want any object to be checked for collision, it should have this on. Okay, so what I'm going to do now is for this one in the calculation model for motion planning, I'm going to say in the robot obstacle collision check in here, I'm going to select that it should avoid this cuboid. Okay, so if I move this cube over here and put it on the way of the last path that it calculated and put it over here, very close to the object, so it's hard for the robot. Let's see. And I recalculate the paths again. So let's uncomment this line so it calculates the paths again and hit play. You'll see that it will try paths that avoid this object over here. Okay? Okay. So what happens if the robot, like this is, for example, exactly in the target? What it will say is that it can't reach it, or just colliding with the robot like this. If I hit play, oh, this one just, okay, so we moved the robot or not. But if this cuboid is on the way and it cannot find a way to go to the target, it will actually tell you an error that it cannot go to the target. Okay, so let me try to do it. So, okay, so this one, what happened is that it calculated the collision, since this is declared as collidable, and this one has a lot of collidable joints, and I put them one inside the other, or like the physics of the engine rejected this first. So I'm going to try to go exactly to the target, put it right on the target, and if I hit play, it should tell me fail to generate a path. Okay, the goal is reachable. Is the goal reachable, or can it be reached without collision? Okay, so this error you'll get only 2 times. Once, what it happens is you set the target you put the target too far, okay, so it can't reach it. The other thing that could happen is that it'll collide an object that you declared, okay? So this is how you use emotion planning for VREP. I'm going to post this. This is on Blackboard. So and this video is accompanied with this scene. So I'm going to put this scene on Blackboard so you can use it. Okay. I'm going to change this one to target. So it's like that for the scene that I'm going to give you guys. Okay. Well, thank you. If you guys have any questions, please don't hesitate to send us an email. Okay. For the last thing, and this is for the motion envelope, once you have declared this motion planning setup, you can actually see the the envelope of reach for this robot. Okay, so if I go and select this group and go to the compute phase 1's nodes over here, I have to wait for a little bit. Okay, when it says done and visualize them, this will give me a cloud of points of all the reachable elements of this robot. Okay, so as you can see, if I go inside the robot, this robot has, you can, I hope that you can see it well, but the motion envelope hits like a sphere inside the robot where the robot cannot reach because it would collide with itself. So it's by this like small sphere that you see here, but yeah, like from all the borders to the small sphere in the middle, you can access all of these points. Okay, so this is what you'll need for the first part of the lab. Okay, so you have to declare this motion planning group for the robot that you want to use, and then after you've declared it right, you need to check its motion its envelope, because what will happen is that in the scene many objects won't be able to reach the places that you wanted to do. And this is great for if you want to set the robot just right. You can select it and move it a little bit, and then, for example, if you want the robot to be able to reach this cuboid over here and it's sitting over here, I just have to go and move it until my motion envelope collides with the part that I want to reach. Okay, so this is all for this tutorial. Thank you.